Good morning, friends, hams and shortwave listeners. This is Vilas, VU to Victor Papa Romeo, Vilas from Pune. We are restarting the Sunday Tech Talks of Pune hams. And first Tech Talk will be on ESD, EMI, EMC, surge protection, and so many enemies of electronics. You all aware about EMI, EMC, ESD? They are so much troublemakers. Sometimes you have to give up the project. I remember when I was in Hyderabad for promoting metal oxide variester, I was invited by the LCA project leader, Sri Hari Kota, and I found the entire LCA was dismantled for rewiring. And they said that they faced so much EMI that they could not run the aircraft. So you can imagine the kind of EMI interferences. There was inaugural DC-10 flight, and pilot refused to fly because he says that when the ground supply was disconnected, a heavy surge came and power supply, 28-volt power supply conk off. He said, I can run the aircraft with one engine, but not when the toilets are not operational. So you can see the kind of interference creates havoc. Makrand Vaidya is a shortwave listener of Pune hams, and he runs his own business, which I have mentioned in my mail. And he has a wide experience in handling instrumentation. Without spending much time, I will request Makrand to start his presentation. We will have question and answer session after 40 minutes. Makrand, there are 40 minutes. At 10 to 15 minutes, we will have a question and answer. So those who are on Echo Link, please switch over to this Zoom link. So QRU 73, have a wonderful day. Over to Makrand.
Okay, thank you. Welcome to all hams and to this episode. Okay, this is the era. Let me start with some brief introduction about before I start the subject. In this era of Google and internet and social media, chat GPT and all that, it is very difficult to make, prepare and deliver any info in this manner. There are different types of presentations we see: a product presentation, a project presentation, business presentation, academic, compilation of information from various sources, well studied and candid. And then some are discourses. Then there are stories. Then there are real life experiences. Okay, and now actually self wisdom sharing based on the experiences and practical performance in the business and profession. I am now going to share with you. So I'm going to attempt this thing, okay, because when I was browsing on the Google and this thing, YouTube and all that, I found that a massive data and massive information is available on this subject: ESD, EMI, EMC, and etc. But I thought of not actually compiling and reproducing the same. Instead, I thought of something different, and then let me share with you the links and various URLs so that you can browse on your own, and together also we can in future will be in connect, and then we can see to it. First of all, this subject is so vast, and each subject can take about 40 minutes. So I apologize for not giving the justice to each topic, but let me actually touch those points and those keywords and those fundamental things. Actually, it happens as Rabde said, the occurrences or the incidences happens, okay, but many times, like in our cases, like hobbyists or professionals, we develop some product, we have got some technology, we have got some intellectual property, we have got some innovation, and then it works on table and it works as we desire. We do some programming in it and etc., hardware and software and etc. But when it goes to the field, or when it goes to some situation, then unexpectedly it starts misbehaving, non-functioning, etc. That is usually means it was working on assembly table or development table, and then it is not working or not functioning as desired. So it happens. That is our usual scenario. Actually, this session or these topics are actually beyond a particular design or a development. It is addition to that. For example, if you have got a product, then a carton or the packing material is the additional thing which you have to put, which you have to take, so that you can ship it or you can keep the product. Similarly, these kind of things are required to run our product very smoothly. The main intention is actually the data integrity. Nowadays, the data which is been sensor data or something is to be captured properly, as well as in right way, as well as it should be transferred or transmitted to the desired location. Okay, usually it is a wireless Wi-Fi, cloud, and etc. Means we are talking about not analog. More other things now are the digital things, digital data. So the data integrity and the functioning of the product as desired is the main intention about this. So now, what are actually concerns I'm going to cover is that very unusual thing I started with, is human safety. Actually, why we should have this ESD, EMC, EMI, and surge and etc. It is for human safety first. So that's why I pointed that thing first. Second thing is the equipment, plant, machinery, the infrastructure, the capital investment, environment, and resources which are already spent on money. So say, for example, as he said about the aeroplane, if that trip got delayed because of some surge or something like that, that cost of delay itself is a huge, and forget about the accident and any other fatal damages and collateral damages. There are different story altogether. So the equipment protection, plant and machinery protection, and human safety are the concerns. And the next concern is the data integrity, accuracy, working of the device and equipment. And the requirements usually are the ingress protection, okay, access control, tamper proof, the things should be, security, safety, already covered, ergonomics, aesthetics, and the last and most important thing is that the following some norms, standards, and protocols and statutory guidelines, if you want to comply, and then if you want to face consultants and customers and other bodies, then these things you have to. In that case, in those cases, these ESD, EMI, EMC plays a major role beyond your product. So your product is as it is, but the other things are statutory, or you can say mandatory. Today's topics are ESD. ESD is the electrostatic discharge. Usually, if you browse or if you see or if you may be aware of it, it is usually a static is actually usually taken it as a human touch or human body which carries static, and the other people suddenly talk about this thing, lightning strike or something like that. Okay, a surge or anything static charge which is coming to the equipment, okay, of any form unexpectedly. So that is called electrostatic discharge. Then there is a radio frequency interference. There are a lot of radio waves and frequencies around us, and those are interfere with us. Okay, and at the same time, let me tell you that apart from I'm talking about or whatever he said about the outside surge has entered into the engine and etc. But same thing may happen with us also. That is our machine also, or our device, our design, power supplies, or anything can also create malfunction and create electrostatics and radio frequencies and noise and all that. Yesterday, I saw one video where the crystal of a microprocessor was generating. It actually is supposed to oscillate 8 megahertz, but it was generating harmonics of the level of some gigahertz, and that was shown on the oscilloscope by that fellow with a magnetic pickup. So these things can happen with our own circuits. Okay, so that has to be taken care. EMI and EMC. EMI and EMC are actually electromagnetic interference and electromagnetic compatibility. Interference is an interference by electromagnetic field, magnetic field produced by outside world to the product, as well as from the product to the outside world, both way. And compatibility is the norm or a body which has been formed so that all people will stick to some standard in which the compliance of the electromagnetic radiation from and to will be taken care, as well as will be in the control. So that is the electromagnetic compatibility. There are huge documents and huge standards are available, materials are available, and you have to follow those things very strictly. And that is based on some committee and studies and all that. Continuous upgradation and continuous changes and updates are happening. Surge is usually as Mr. Rabde only told me, swelling and it's like a dip and the high of the power supply component, okay, which takes place for a momentary thing because of various reasons, okay, switching of things and all that. Then grounding, shielding, and earthing. These are the major concerns and major things in cabling as well as in the equipment connections, I should say. Okay. And X-proof. This actually I added to this topic or merged to this thing because this is my forte and this is my profession I'm working in. X-proof is explosion-proof equipment protection for hazardous area, for into the courts. It does not mean X-proof does not mean that in the explosion the product should stand. It is other way. Our product malfunctioning should not create any explosion into the atmosphere, because outside atmosphere is the hazardous gases and air gas mixture. So our equipment, if malfunctions, if creates some spark, if happens to be creating some ESD or magnetic field or some frequencies, then it should not affect, it should not blow, or it should not make any accident. So that is the main concern or main thing of X-proof. It is not about the protection of the product, it is about the protection of the human beings working and the machinery and the plant and infrastructure investments. Okay. So now what are the occurrences? There are different occurrences of this ESD and all kind of enemies, as he said. It's a susceptibility. Sometimes our devices, our product, our designs are susceptible for the such delicate, I mean to say, to such things, and then they are exposed to the radiation, and then they react or they malfunction. Same thing, the outside devices are susceptible, and then our device creates noise. For example, say drive, VFD. If that VFD is designed very nicely, but that VFD can variable frequency drive, that can be a problem, and that can be a situation for the other devices, nearby controllers or something like that. So susceptibility. Then second, incidences. Some incidences happen in the plant. Some are accidental, some are planned, some are routines. For example, some new installations happening. So in that case, something happens. Then some switching of conveyors, some switching of big loads like pumps and blowers. So those things may create some incidents, so that in that the surge and this magnetic field can develop. Then the creation. Sometimes the ESD and the magnetic fields are created for testing purpose and for audit purpose and all that, for inspection purpose. Then control. Sometimes it is a controlled activity in which the all kind of radiations are happen, and you have to cope up with them because they are already there, so you cannot just ignore them. You have to monitor these radiations for the routine thing. And audits are also there, and the adoption of standards. This also calls for the taking a note of EMI, ESB, and EMC. The scenarios are, as I already said, the product is reviewed and testing and to use, and then something happens, and then there is a power supply which actually um, misbehaves, or which lacks the power, or which delivers the power of the higher voltage and all that. Usually this surge itself is actually well explained. It is for millisecond and it is always for short period. So, but that is damaging. The different types of loads usually in the field are inductive load, capacitive load, and resistive load of different magnitudes. The magnitude is very important. For example, if there is a big load, and as compared to that, our controller or our relays and all that things are very small in the capacity and the power consuming, then that affects tremendously on our small capacity products. So magnitude is also important apart from the type of load. Moisture, humidity, in a day, 24 hours also, the atmospheric condition changes so much. You have to think of rainy season or winter or summer kind of. In the same day also, the things happen so much that it all creates different scenes and atmospheric conditions. And then that causes problem, moisture condensation, etc. Water also can enter because of some other reasons, and that creates a lot of problems to product and the situations. Temperature is one of the big concern in electronics and process industry, because temperature is one of the cause of explosion, cause of accident. Among three, the triangle of fire, among three, one is the temperature and other is the fuel and the air. So temperature is not to be ignored in any case, because and we actually not prepared, and we are actually not intend to create the temperature, but it happens. So it is unavoidable sometimes. But you have to take care. Sunlight and UV are also make a lot of things bright, sunlight and all that. They create a lot of problems to equipment. Lightning, it is well known that the surge and ESD happens with the lightning, and the lightning is discussed, and lightning is a subject of almost unknown to everybody, and it is everybody is actually developing various things of how to deal with the lightning. It is completely unprecedented and unexpected thing happens when the lightning strikes to the plant and to the, say for example, the earthing, and it can come and enter through earthing to back to our devices. It happens. So the ESD protections are provided to arrest that lightning and divert that energy into the earth, again back to separate earth, we can call it, because the weak earth has already been damaged. Static materials movements are there. For example, human being is a static material. At the same time, there are various static materials in the plant and around, and then they also cause things. Store energy. Capacitors, batteries are stored energy devices, and those inductor is also kind of stored energy device. So, and then that also is a concern. Magnetism and radio frequency, actually, as you know, earlier it was only a radio. Now there are so many things which are radio frequency generators and around us, including mobile. Mobile is very close to us, and then other things. So those are all actually factors, and that way they are the concerns nowadays, and the developments, and on the other hand, our products and the technologies are going into direction of very high speed, high frequency, and they are demanding accuracy, data integrity, rate of data, and etc. So all these things affecting to that is a concern. So there is no point, there is no way our product will work in such a situation. It will work in ideal situation. Radiations and radioactive are also one of the factors. Vibrations and G forces are also one of the scenes wherein the things can uh, create problems. Ultrasonic and sound also is the energy. Basically, these all things are actually dealing with the energy. So if you control the energy, and then if you, and controlling energy means what? It is a voltage and then current. Limit the current and control the voltage. Then everything is can be settled down. Okay, so you have to continuously take care of that and control of energy. Okay, and beyond that, actually there is nothing as such, and you have to divert the energy if it is excess. The most common problems, actually you can list n number of problems. We can discuss individual problems. Okay, but actually let me share with you the most 90% you can call it as problems are actually with the power supply. They are insufficient, they are improper connections, then there are improper potential, then there is a design problem, then sometimes they are worn out, they are expired, they are old, lifespan is over. And the second most problem is the terminations. Terminations means our connectors, our plugs and male female plugs and terminal strip and wires, and we do wiring. Then the lugs, then there is a dressing of wire, then there is a you can call it as crimping of wire, etc. Those are all factors. They are not at all casual or to be taken as a granted, because all those things are affect. They all affect some noise. Some noise is always happens because of such reasons. So if you tackle tightening of the termination, sometimes what happens that the terminals do get loose or terminal do get too tight. Means they are tight, but they are not actually physically in contact. Some oxidation takes place to the contacts. So you have to keep on maintaining them, keep on retightening, loosening and retightening, redoing the connections. Okay. So if you can tackle these two problems, then almost many problems are solved. And now the rest of the problems may be there, which are very specific or very means localized, I mean to say. The diagnosis, for the diagnosis of these things, okay, one can say for EMI, EFI, radiations and all that, there are the probes and magnetic pickups and all that. Okay, but we'll start with the meters, multimeters, I mean to say, oscilloscopes, LCR meters, then logic analyzers, harmonics testers and all that. For sensors, Hall sensor is the best magnetic pickup. Then contactless, and then simple magnetic pickup is also there. And thermal imaging, actually, I wish to introduce over here. Thermal imaging is going to be a I think it is a good point to have a thermal imaging of your circuit while developing, while testing, at the same time while auditing, or while in the while it is in working condition. You have to have that checkup of that what is the heat developed or heat generated while working. That also indicates that any malfunction happens, that abnormal heating happening or not. Okay, that is also can be assessed. So thermal imaging is a main thing, I should say. Okay, continuity is a simple thing. Then mains tester. I listed these two things because we are very conversant with that. But these are the diagnostic tools. Maker. Many times I found on the field that nobody actually knows what is Maker. Though I have written those last three topics as continuity tester and then mains tester and Maker, but these are very primordial, but at the same time very much useful and very convenient, as well as must things. Okay, at one side the motors were on the two storms, and then there was a rain. Goa, it was the Goa side, and all the motors were connected, and they were about to start them. But I told them that you have to take the measure, otherwise just don't touch it. And I found that all the motors were failed to measure. Okay, it's an insulation test, actually speaking. So the plant people were not aware about that thing. I was surprised myself. Mitigation, how you can tackle such situations. The first and foremost for our hobbyist and our electronic engineering is the PCB design. PCB design itself is a huge and vast subject. So it has various aspects. And nowadays people are talking about not a single layer or two layer. They talk about multi-layer, 4-layer minimum and 10-layer maximum. So they talk. But the bottom line is that the ground track has to be very nicely done. Then there should not be loops, and there should be least distance traveled for the tracks. You should not have luxury of making the antenna out of track. That means the track should not look like an antenna, S shape or zigzag shape. There is no need. You can have other alternatives, but don't just do it for the sake of designing. Okay, the track width. Once I read somewhere that actually the track carries our electrons and our current and voltages. Okay, and the static is not on the track. Static is not on the copper. Static lies in the material of the PCB. That is this thing, static material. And we have to give the path to that electrostatics to the track, and that too the track width has to be sufficiently big enough as far as ground track is concerned, so that it can sink that much of energy. Because if you design a ground track only for our purpose, which is a milliampere current or microampere current, then it is not going to suffice the purpose of draining the electrostatic charged thing to the ground. So track width is very important. Separation of tracks and separation of components like terminations, like analog, like digital, like processors, like this thing, sensors. If the sensor inputs are coming, then there has to be some isolations and all that. So separation of various PCB components is also very important. You just cannot have mixture of the things from one part to other part. Isolations are very much required, because if something is coming from outside, if it is not isolated, then it is straightway going to hit our circuit. So isolations are there. Isolation types are magnetic and optical. Magnetic isolations are also there. Power supply, VCC, there are various kinds of power supply, and we have to, every power supply has got their own role and their own pros and cons. So we have to deal with all those. You may have to mix them, because SMPS, switch mode power supply, means best. ऐसा कुछ नहीं होता है. So you can decide upon by the experience and by the requirements. Dielectric of the material, PCB material is also. Composite tracking index of a PCB material, that is also a thing. Thickness of a PCB is also. Then about product design, the enclosure, fittings and assembly. We usually ignore, or not, I should say ignore, but we overlook those things. But these mechanical assemblies and mechanical fittings and fixtures are very much important and to be taken very seriously. For example, washers, spring washers, size of the threading, etc. And there should not be any compromises on, because at the hobby level and at the you can say POC level, it's okay. But if you want to build a product and which should last on the plant, then those should be taken very seriously and carefully. Safety first while designing and while developing anything. Safety, human safety, and the plant machinery and infrastructure safety is the most primordial thing. Everything comes afterward. After that is the thing. And safety means everything. Safety means any bruise or abrasion or because of the our product. For example, sharp edges. That is also not, or the heat. If something is we are going to touch and there is a heat or some 230 volt, etc. So those things has to be taken with a something like self protective connectors or terminals. So we have to take care of that. Even now, about separation, I said about we have to separate 230 volt, 24 volt DC, 5 volt DC, 3.3 volt DC, battery power supply 1.8 volt, etc. etc. So those has to be separately done. You cannot just mix with things because things can switch, things can interchange. There are no shortcuts in the design, and यहाँ सब कुछ नहीं चलता. This should be the attitude. Other mitigations are component selections. Nowadays, I'm not talking about the component quality because I assume that we are sourcing right component. We are while designing, we have used the data sheets and specs, and then the designer has done his job. But I'm not talking about the quality. You may be calling for a mill grade chips and components, no problem because it might be the requirement. But nowadays, the sourcing is a big issue because of various international level problems. Okay, so right vendor is now the big task. Then the genuine, and I should not say duplicate, but there are some issues like China and all that. So genuine component is the issue. Then original and duplicate is the issue. Then material of construction is the issue that is to be because it is now very happening. For example, I saw and I was shocked, and entire our education is going into different direction. I could see there is no copper leads nowadays on the diode and all that. I think there was some brass and all that, but now there is no brass is also not there. It's MS steel, and those kind of leads we are using. And how come we can expect to? They are tinned actually. They are tinned MS leads, but still they are not copper. That is not actually a. I don't know what is going to happen. Consistency in the supply. There is also problem of consistency in the supply. Then obsolescences are happening, and the concern of the consultants and the big MNCs and all that. When you design or develop something, they ask you document to submit to them from vendor so that the obsolescence will be tackled for say 5 years of the support and all that. Because otherwise, if you develop something and then because the things are getting obsolete very fast, and then your design goes because of some component, and then you have to replace everything. Versions is also a big issue nowadays. After sales support is also required. Compatibility is the issue nowadays. Right tools and tackles. That is also what I learned in my life. Is that every time you have to have right tools and tackles while you work. Okay, including pliers and screwdrivers and star shape and everything. You should have all the things right thing at right place. I advise you to do a lot of homework before attempting anything because you just cannot, in enthusiasm, you just cannot sit and start working. You have to do a lot of homework before attempting, and that helps. Homework will take some time, but it helps in developing. In hurry, you do things wrong actually. There is a need of amateurs to become a professional. So that is also one kind of thing which can take care of our own concerns. Various techniques. Now I think it is 37 minutes. My God. So various techniques in the ESD and EMI and EMCs are. I started with a fuse because fuse and earthing are from childhood itself. We have learned about that fuse. First protection device we come across, illiterate, small or less educated or whatever, is a fuse. Then came the circuit breaker, ELCB, earth leakage circuit breaker, RCCB, MCB, then earthing, which are very converse. That's why I listed over here. Then came the things like surge protection and all that, MOVs, metal oxide various stuff. Then gas discharge tubes. Then I can write a full form also because GDT, if you type in Google, you will not get that glass discharge tube. So let it be. But I will give you the thing. Then regulators, voltage, current, constant voltage, constant current sources, regulators. So these are the things which are base of our EMC or the surge protections. Okay, diodes, then Zener, and then TVS. TVS is a device. TVS is a diode developed for surge protection. TVS responds to the short spurts of surges very fast. And GDT, gas discharge tube, doesn't respond to that. So in conjunction with GDT, the TVS both will take care of the huge energy control. So there has to be designed actually. Actually, in these techniques and these technologies, there is no trading or there is no products or there is no what you can say ready-made solutions. It is a system thing, system business. You have to develop a system, okay, and then integrate it. There is no single solution for the particular problem. Schottky diode is also used for protection, as a protection, polarity protection sometimes. Opto isolator already said, magnetic isolator already said. Current limiting resistor is also very much used. I use regularly. And other things are polyfuse, resettable fuse, PTC, positive temperature coefficient sensors. They increase their impedance, resistance in proportion with the temperature. So it is used as a resettable fuse. Decoupling capacitor is a huge subject. On this subject, I can talk for 40 minutes actually. These are very much required to filter down various frequencies of noise. So minimum 3 frequencies are tackled by decoupling capacitor, and common mode reactions are done, and then we presume that the things are okay for the protections. Shunt circuits are there, which shunts the, just like our railway shunting, it shunts the energy from the circuit to the earth. So it is called shunt circuit. Crowbar is one technique. That is also huge subject. That technique also shunts, not shunts, it actually prevents any damage to the product or any damage to the environment, both ways. Inductors are used sometimes because of wiring and because of various things, the capacitance increases in the circuits, and then you have to reduce the capacitor. The only one way to reduce the capacitor is the introduction of inductors. Heat sinks are very much, and it's a proper in mechanical engineering for the heat sink. You have to do that thing. Spacing, you cannot just make the congestions. Mechanical strengthening, as already said. Grounding and ground earth is a different concept altogether. Grounding is our zero reference of the circuit, and ground earth is that you ground this potential to the earth. So that is the ground earth. And earthing is the other thing. Earthing is actually a non-potential entity you are connecting to the earth. That is called earthing. This is a potential which might be a zero potential or a voltage, but that thing you are grounding, so that is called ground earth. So that is a different. Shielding is actually a cable or the conductor which has got a shield sheet. You might have seen the LAN cable, Ethernet cables, or even the telephone, old telephone cables. They were having that shield and screen. So that is very much can have the antenna effect of catching the electrostatics, and then you have to properly ground them at one end, not at the both end. If you do it at both end, then that shield becomes a conductor, so it is useless actually speaking. So we don't want to have the conductor. We want to have the antenna to catch the radiations from environment onto the cable, and then you have to drain them to the earth. So the shielding has to be done at the one end. Usually it is equipment end. So now my 42 minutes, my presentation is over. Now I will now keep on 3 slides, okay, further, which I have actually added after this last slide, because that is actually, that triggered me that when I was browsing various standards, just I picked up one standard, okay, X-proof, that is intrinsic safety. And I could see that how many tests or how many requirements are there by the testing bodies, testing certification agencies, consultants. I was very much interested to share with you. See the depth of thinking and depth of information nowadays people expect from you. So, Mr. Rabde, we can have the question and answer.
Yeah. So thank you very much, Makarand, for excellent overview of EMI, EMC, ESD, Sag Serge, whatnot, all the enemies of electronics and their mitigation techniques. Of course, we could not go into the depth case by case. That will take more time. But you have suggested the right solutions for various EMI, EMC problems. Now we'll throw open the forum for the discussions and chat and question and answer. So please raise your queries, identify yourself, and then raise your queries.
Hello.
Hello.
Good morning, sir.
Good morning.
This is Ajit. I'm working in ARAI. I have
Okay.
one doubt. I am working on the EV batteries basically.
Okay.
So you said that batteries also causes these kind of EMI, EMC and other issues. Can you please give little bit more elaboration on how lithium-ion batteries actually?
No. What I said about is that in EMC document, okay, which is international document, and all the countries are actually following that document. In that they have got special chapter or special clause for the batteries. What I mean to say is that any energy has to be tackled or has to be taken into consideration for these kind of things, because our battery is for our own purpose, and then we are handling that as an energy source, but that should not cause a problem to environment.
Okay.
That should not cause that should not cause, so that is a concern. So the compliance with the electromagnetic, the compliance with the EMC regulation has to be done. That's it. So
okay.
Whether that lithium battery is prone or whether that's susceptible, that is a different story. But that we have to study and go through that spec sheets or the statutory requirement and follow that. That's it. Nothing more.
Yeah. Thank you, sir. Yeah.
Welcome. Here I have written, Mr. Rabde, here I have written something different word. In our college days, we learned about or even our plants also. We learned about the preventive maintenance and breakdown maintenance, right? Servicing, right? But here I have written preemptive maintenance. That means in anticipation of anything to happen. I mean to say. Hello?
Yes.
Borobar, na?
Go ahead. Yeah.
And then these things, these types of tests, these things are they have been taken in cognizance. For example, continuous, occasional, and non-likely situations. So such depth, the auditors or the statutory bodies go into depth to see if something goes bad or wrong. Nothing is taken or nothing is left as a casual thing nowadays, because we are too much now in electronics or too much now in technology, I mean to say. So that things are there. So these sheets are, these last slides are also very important, frankly speaking.
Yeah.
Gaskets. They talk about gaskets nowadays.
EMI, EMC gaskets are also available now.
No. I mean, what I mean to say, they don't leave anything nowadays. They just plastics and elastomers, and then they differentiate between the metal objects and plastic elastomers, because plastics are all statics, na? So, and the metals are also the carrying the currents, na? So both things has to be deal. MOC is also very much, and it is a problem nowadays actually.
Yeah. Any more questions?
Yeah, namaskar, sabko. Or we have question from Sunil Dhageji that how do we mitigate with Z problem with 230-volt AC operated equipments? Third, sixth, and ninth harmonics are getting emitted. So how do we mitigate with them? That is question by Sunil Dhageji.
I have to study that. I cannot just give the answer to this on the spot actually. But I'll please post me that question. I will see to it. Dhageji, please post me.
Yeah. Yeah, this is a typical case. So,
Ah,
right now we cannot give a
yeah.
100% correct
Yes,
answer.
yes.
So better to post it, then we can
Yeah.
find out and let you know.
Yes, yes. Because daily I tackle the issues, but every issue is as once Rabde only told me that every issue is a special issue.
No, I
And
always, my guru used to tell me
ah,
EMI mitigation is a black magic. The solution found for A may
ah,
not work on B.
hmm,
So you have to individually tackle it.
hmm,
And it depends upon your layout, earthing, so
yeah,
many factors
yeah,
while considering
yeah,
the EMI mitigation techniques.
yeah.
Sir, good morning. Girish Ranade here.
Uh-huh.
I don't have a query, but can I narrate one small experience of
Yeah,
ours?
Yes, yes,
sure,
Yeah.
sure. Go
very,
ahead. I was
very
happy.
much.
Sir, we are making test equipments for last many years now,
Hmm.
and I'm designer by education.
Yeah.
So we designed in such a way that we we could take EMI EMC tests.
Yeah.
That's what my thought behind design.
Hmm.
So what we did that we designed our test equipments on 12-volt DC power supply.
Hmm.
And we selected a C mark power supply, which is imported, meanwhile. And then I thought that everything is okay now. I can go for EMI EMC.
Yeah.
But what happened is that
Hmm.
all these power supplies, SMPS supplies, are C mark for IT. What I can say, IT module or for IT. And our equipments are industrial equipments. So the requirements of IT are exactly half that of industrial.
Oh,
What I mean to say is that if industrial has to withstand surge of say 2 kV, then IT is 1 kV.
uh-huh.
So it doesn't work that way, definitely.
Yeah.
And meals maybe it, 2 times is what you are discussing. Yeah.
Sorry,
No, military requirements maybe 2 times what it is mentioned.
maybe it is 2 times that of industrial.
Yeah, maybe,
So
yes.
selecting merely a C mark power supply doesn't help at all. I mean, after 30 years of, even after 30 years of experience, I faced this problem. So I would like everyone to be careful, and what sir rightly said in his presentation, that every system is different and we have to go into really depth in that. Otherwise, it's
It's
not
a system
really
business. It's a
good.
system business. It's not a product which you can put and then get rid of.
Yes, that's it.
No, I think, but Girish, C marking is meant for, it should not create any physical injury to the
Yeah.
person who is handling it. Or does it have the EMI, EMC requirements also?
Yes, very much.
Okay.
EMI EMC is part of C marking based on your type of equipment and
Yeah,
whatever you declare design.
yeah.
So based on that, you have to carry out EMI EMC test as per standard.
Okay.
And
Girishji, one more thing I found after say 30 years of experience also, that we talk about the digital signal, which is a square wave, and that rise and fall of the wave itself is a harmonics.
Yes. Okay.
So that and that we are talking about gigahertz now. So
Correct. It's very fast.
So we are every day there is a challenge. Actually, in December 22 also, I saw some development in that these kind of things happening, and it's continuously happening. That means our vendors cannot just deliver the IC or whatever device. You have to go on hunting for those things by paying the premium and all that. But it is happening nowadays. There's no escape. We are going too fast.
Yeah, Girish is expert also in EMI, EMC mitigation because he has industrial experience and industrial products in his range. So thank you, Girish, for raising a valid query.
Yes.
Thank you, sir.
Any more questions, or do you have, Girish, any more inputs to share?
Yeah, please, Girish.
I have one question. If you
Identify yourself.
This is Shaunak. I'm from Pune. I run a tech company in the space of IoT and AI.
Yeah.
Now,
Okay.
question specific. Okay, so the reason why I joined this call
Yeah.
was because during COVID days, when we were working on an IoT chip,
Yeah.
which had Wi-Fi microcontroller on board.
Hmm.
So we were getting a lot of electromagnetic disturbances here and there, and
Yes.
our sensors send telemetries, and that telemetry is supposed to train an AI model, right?
Ah,
So false data was, needless to say,
yeah.
extremely important for us to avoid.
Yeah.
Now we did all of these diode configurations,
Hmm.
figuring out how to distance the electronic components so that EMF is reduced. But one trick, one thing in the book which I wasn't able to try was ferrite beads.
Yeah.
And
I forgot that actually. Ferrite
yeah,
core. Ferrite
how
core.
do you efficiently use it? And is it really, because uh, it is a very to be very rough in words, it's a very rudimentary. It appears to be a very rudimentary.
Appears to be rudimentary, right?
So does it really help, and how to use it?
Yeah, it helps. It helps actually. But I said na ki it is no solution is the right and correct solution. But ferrite core appears very rudimentary and very but it helps because look at the keyboard and mouse and our computer things. They have got ferrite core. It does help actually. It does
Would it
help.
would it help in 3.2 volt circuits or digital circuits? Very
Yeah,
little.
yeah, because keyboard and all that are all 3.2 and 3.3 volt and 5 volt only, na? They
Yeah.
are helping.
Thank you.
You have
Okay.
to you have to look to try it, actually speaking. And one solution will not work. You have to shielding. Shielding is also very much thing.
Yeah, in one of the rooms of a client, there was an AC which they, sometimes put it on swing mode, sometimes did not.
Yeah.
So whenever they put it on swing mode, I used to
Ah.
get a lot of disturbances.
Right,
My
right.
sensors weren't even in the range of the air. It was
Stepper motor. There is a stepper motor, na, in the swing.
so little things like that. So I was very
Yeah.
amused when you say,
Yeah.
your guru said it's like working with black magic.
Really, really. TVS diode will help you. TVS diode, transient voltage suppressor diodes. And 3 diodes. That means one in voltage, one in ground and VCC ground, and the third one bidirectional in VCC ground across. That is like similar like common mode rejection kind of
Mhm.
decoupling kind of.
All right. Thank you.
So that will work.
Yes.
So, any more questions now? Because
Yeah,
I'm-
myself, Sunil Dhage. I am from Pune, Phi Audiocom Systems Private Limited. Yeah, we are manufacturing communication system for Indian Navy.
Oh,
Right now, we are developing some products for Coast Guard requirements. In that, they need a communication equipment which has got the Snapdome keyboard.
Mhm.
Yeah. We were trying to test it as per some IEC standard, as per IRS requirement. Yeah, in that we encounter one problem when we have taken a lot of protection. Means we are using Snapdome keyboard, we are using this earthing EMI EMC gasket. We have removed the paint where the surfaces are overlapping, and good copper clad also we have used. But when there is a 1 kV ESD test on keyboard, no? It got malfunction. And it doesn't come automatically out of that problem. Means we need to switch off and then on equipment, then it will function. But as per their requirement, human intervention should not be required. So what additional care we should take to mitigate this problem, sir?
Sunilji, can I share? You all are actually very senior and very experienced in actually the field, and
Sir.
it is like a test to me. But still, I want to share. At
Sir.
Sipla, this thing, Kurkum, I had a problem, and
Sir.
then there are 2 issues actually with such kind of things.
Sir.
2 issues. One is that you cannot have human interference. That is absolutely right. There should not be human interference. But
Sir.
at the same time, you cannot restart also. If the situation that you have to restart the plant or machine, that is also not advisable. Na? So,
Yes, sir.
yeah. So if the restart is allowed, for example, some there are various things like keyboard. Keyboard can be restarted. Keyboard doesn't require to be. It is not going to halt your process or any equipment, right?
No,
Same
sir.
functionality.
Means requirement is like that. Suppose there is one key. Let us say it is D1,
Ah.
and customer presses D1 key, and he is making the broadcast announcement all over the ship.
Yeah.
At the time when he touches the keyboard, that equipment should not malfunction, because that is the emergency announcement
Yeah.
he has to make.
Yeah.
So we
So what I
cannot
did.
restart. Yeah.
No, restart
Sir.
is not at all advisable sometimes. But if
Sir.
it is restart is advisable for say particular device or particular equipment, then
Sir.
what I did, actually I'm little bit of shy to advise you or to share with you, but still I'm going ahead.
Sir.
Actually, I did a watchdog timer, then I reset the thing, and I hope that it worked, but that does not mean it will work for elsewhere.
Understood, sir. Understood.
So watchdog timer, and watchdog timer also in COVID only I developed that.
Okay.
Watchdog
Okay.
timer also, there are 3 designs you can try. One is a hardware watchdog, hardware reset.
Yes, sir.
CPU watchdog itself, microcontroller watchdog itself. And the third one is a parallel processing. That means the other process is also working, and
Okay.
it triggers the it monitors our processor.
Okay.
And then, for example, if you are using ESP,
then
then ESP has got dual core, na?
Yes, sir.
So the other core can be just try. The other core can be put for the watchdog.
Okay. Okay. Understood, sir.
But
Understood.
that does not mean that is the final and that is the solution. You have to.
Yeah. I can understood that key. It is the situational. It will be situational based solution, not unique for all the equipment. Understood, sir.
Actually, I manufacture that purge and pressurized controllers. So just
Okay,
I cannot afford to switch off the thing or restart the thing.
Understood.
But the keyboard and the display panels,
Yes, sir.
consoles can be refreshed and can be restarted.
Okay. Understood.
So you have to convince the customer, consultant, and situation, and then can
find some solution.
Also, I suggest you have to isolate the problem. You have to pinpoint whether it is coming from keyboard or something else, power supply.
No, sir, keyboard is susceptible, he said. Keyboard is not a problem. Keyboard is a susceptible.
Susceptible, okay. Yeah, because normally if you cannot solve the problem theoretically, the problem lies in power supply. That is what my experience is.
Yes. That's why I said, connections and power supply. Connections and power supply.
Basically, check the voltage regulation of the power supply, whether it is below specification, and the ripple. These are the 2 enemies of power supply, which if taken care, a lot of problems can be resolved.
Okay, sir. Okay.
So reconfirm the ripple content in the power supply and regulation of the power supply.
Okay, sir.
So friends, we are coming to an end now. 2 minutes left. So you can post your questions to myself and Yankee Echo Juliet, and we will give all the questions to Makarand, and we'll try to get the answers. I will request Kunal to propose a vote of thanks on behalf of Pune Hams.
First, I should thank Mr. Vilas Rabde, VU2 VPR, for giving me this opportunity, and Mr. Kunal Gautam, VU3 YET. Right? I pronounced it. Then, Rabdeji, what you say about Pune Hams VU2 RCP?
RCP, yeah, it's our club.
I thank them also for patient listening, and our own Tech Forum audience. Okay, thank you all very much. We'll be in the touch, and then I shared with Mr. Rabde various keywords and various.
So we have recorded this session, and we will send it across for you. Yeah.
So that links are very useful in this subject. People are working and doing a lot of things in this field, actually.
Yeah. Thank you, sir. Thank you very much.
So, Kunal, please go ahead with a vote of thanks.
Okay. So सबको नमस्कार, और मकरंद जी आपको भी नमस्कार. बहुत अच्छा आपने इंफॉर्मेशन शेयर किया, बहुत ही शॉर्ट एंड प्रिसाइज, क्योंकि ये जो मैटर है ये मैटर ऑब्वियसली जो जितने भी मैटर हैं वो इतने शॉर्ट टर्म में मतलब एक्सप्लेन करना कीवर्ड्स को, एंड उसको मतलब